Hi friends, this video is on motion of physics part 14 out of 14. This video is brought to you by COACHINGCARES.IN, designing future by smart education. Under this lesson, we'll study uniform circular motion. What is uniform circular motion? So far we study actually rectilinear motion in the previous chapter. That is the motion in a straight line. I mean, there are two types of motions. One is the rectilinear motion. In a rectilinear motion, object moves in a straight line. That is called motion in a straight line or rectilinear motion. Another motion is when object moves in a circular path. That is known circular motion. Circular motion, a body is said to be in circular motion, uniform circular motion, if it moves in a circular path with uniform acceleration. Yes, circular motion is definitely the motion when body moves in a circular path. But when we say uniform circular motion, then body moves in a circular path with a uniform acceleration. How it happens? I mean, you just see this example. This is a straight rectilinear motion. If suppose body moves in a straight line, suppose some uniform velocity, say 10 meter per second is 10 meter per second. So there is no change in the direction of the velocity. So there is uniform velocity and there is no acceleration in this. If suppose the body moves along circular path, I just take this example. Suppose there is a body which is moving in this circular path. Okay, I take this. In a circular path, the body is moving. At this path, suppose this body is moving with a uniform velocity, say 10 meter per second in a circular path. So the direction of this velocity will be tangent to this circle, like this. And suppose the body moving again, suppose we at this point it is reaching the tangent, or at this point will be the direction of this, and at this point the tangent of the direction of this body. This will be the direction of the velocity. So what is tangent basically? Tangent, as you know, tangent at any point of a circle, there is a line which is touching the circle at a point, at single point, that is called tangent. I mean, suppose the line is touching at this point, so this is a tangent line. So tangent is the direction of the body velocity in a circular path. So suppose this is moving with a uniform velocity 10 meter per second. So there is no acceleration. But if you'll see, if you'll notice, each and every point, it is having different direction. Here is direction is different. Here is the direction of velocity again changed. Here is the direction of velocity again changed. So because of the direction change, so there is a acceleration, and the direction, it is changing in a circular path in a uniformly it is changing, so there is a uniform acceleration exists here. So we can say the uniform circular motion. Under uniform circular motion, when body moves in a circular path with a uniform acceleration, then body is said to be in a uniform circular motion. So you can understand this by this example. Suppose this is a straight line or rectilinear motion, body is moving in this direction. Okay, so I take the same example, about 10 meter per second, and after that body moves in this direction, but the velocity again is a 10 meter per second. Then after that body moves in this direction, but the velocity magnitude is again 10 meter per second, and body again suppose move in this direction with the same magnitude 10 meter per second. So now can you understand there is acceleration exists here? Yes. Why? Because yes, of course, velocity is uniform. I mean, velocity is constant. So, but there is a uniform velocity and there is a uniform acceleration. Why? Because this body is changing direction or the velocity, the change of direction of the velocity at this point, at this point, and at this point again it is changing the direction. Because of the change of the direction, there is uniform acceleration exists because of the uniform velocity, but there is a change in the direction, that is 4 times in this way. So like that you can say, I mean, if the body is moving, suppose from here to this way, here to this way, then going this way, this way, this way. So like this, suppose I just take one example. So there is change of the direction of the velocity. If it is moving with the uniform velocity of say 10 meter per second, but you can notice it is changing the direction. Velocity direction is being changed at this point. 1, 2, 3, 4, 5, 6, 7, 8. I mean, there is change of velocity at 8 points or 8 times it changes. So there is a acceleration exists here, or we can say there's uniform acceleration exists. So we can understand, I mean, this way. So in a circular path, when we study this, so it happens, I mean, in a uniform, when we add this term, when we study the uniform circular motion, then uniform acceleration exists in this motion. Now we'll understand it by with the example. We'll study a stone tied in a string. When a person is moving this stone, suppose a person is moving one stone. There is a stone here which is tied with this string. So it is being tied with the string, and a boy or a person is standing here at this point, and it is moving this stone around in a circular way. So this stone is moving, uh, and you can notice, each and every point, the direction of the stone, it is being changed. Direction of the stone is, tangent of the circular path. And if you notice, if suppose this person leave this string, then this stone will go away in which direction? In the same direction. I mean, the direction of the velocity. In this way, this stone will go. Suppose this boy leave this stone here at this point, so this stone will be thrown the direction of the velocity at that point, at that instant, it will go in this way. So it happens. So but why this stone is moving when it holds the stones and move around? Why the stone is moving in a circular path? Because of the force exerted through the string by this person. So that's why it is moving towards, I mean, in a circular path, and the force is being exerted towards the center of this circular path. So like this, we can understand very easily the direction of the stone in a circular path. I mean, direction of the stone is the tangent of that circular path. And if suppose it is holding this stone, then it gets a circular path. And then the motion is in a circular path. So because of the force, which is every time it is trying to be applied, or to be try to tends to be applied towards the center of the circular path. So I hope you can now understand completely the circular motion. So in this chapter, I mean, so far till now we studied rectilinear motion, that is straight line motion, and the circular motion. Now the second one, that is in a circular path. So you'll study further in details in further class this, I mean, numericals and the derivations of circular motion. So I hope you are able to understand now clearly about circular motion with this example. So thank you very much for visiting coachingcares.in. Watch free educational videos, get best quality study material, study from the best tutors and mentors. Thank you once again.